Many advanced life science applications require more power than a single laser can achieve for measuring minuscule particles. One way to overcome this issue is to combine two lasers with the same wavelength into a single beam. In practice, it can be difficult to maximize how much light is captured from each beam and to achieve collinearity. Hi, I'm Ehren O'Donnell, Product Line Engineer at Edmund Optics, here to talk about how to efficiently combine two beams with the same wavelength utilizing polarization. Utilizing Edmund Optics components and a highly polarized laser like the Coherent OBIS, this combining technique is fast and easy. When combining laser beams together into a collinear path, dichroic filters, also known as dichroic beam splitters or dichroic mirrors, are typically used. Dichroic filters separate the incoming spectrum and transmit one wavelength region while reflecting another. Using this optic in reverse works well when combining beams of different wavelengths, but does not work when the lasers have the same wavelength. Another common way to combine light is to use a 50-50 beam splitter, which reflects half the incoming light and transmits the other half, regardless of the wavelength or polarization state. While this technique can combine two beams, you will lose half the power of each beam. Instead of focusing on regions of the spectrum, we can also focus on polarization states. If two beams have the same wavelength and orthogonal polarization states, a polarizing cube beam splitter will combine the light. Similar to a dichroic filter, a polarizing cube beam splitter will transmit one type of light and reflect another. In this case, P-polarized light will transmit and S-polarized light will be reflected. In order to combine two beams using polarization, you will need the following: two OBIS lasers with the same wavelength, one polarizing cube beam splitter, two mirrors to make one set of folding mirrors, and finally one OBIS cage combining kit. Each laser will need to be mounted such that their polarization states are orthogonal. Then, with the polarizing cube beam splitter in place, use the adjustments on the kinematic mounts to turn the lasers until they are collinear. Now, when you measure the power of the initial beams, you'll see that the resultant beam is the addition of their powers with minimal loss. To learn more about creating your own system for combining two beams, contact us today or visit our website at www.edmundoptics.com.